So differential calculus, we also call it differentiation. It is also called the gradient function. So if you have got a function, let's say y, which is equal to 2x squared, they say differentiate this one. To differentiate this one, since you have got y here, you are going to have dy over dx. That is going to be the derivative. So you get the 2, you multiply with the 2 here. Okay, so that is 2 times 2. That gives you a 4. And then you write your x. Now this power, you are going to remove a 1. So it becomes 2 minus 1, so that will be power 1. So this is called the derivative of 2x squared. This is a derivative of 2x squared. Is this okay? Okay. So if you have got, let's say, y is equal to 3x to the power 7, let me say 3x to the power 5 minus 2x plus 4. You want to differentiate this one. So to differentiate, this will give you dy over dx. That will be, you get the 5, you multiply with the 3 which is down. That will give you 15. Then you write x. Now the 5, you remove a 1. 5 minus 1, that will give you 4. Okay, then minus. Now when you are differentiating something that only has got x without a power, when you differentiate, the answer will just be this negative 2. Okay, and then when you differentiate something that has got no x, it will just be 0. So I was supposed to say plus 0. Now I will not write 0, so just write it like that. This is the derivative of 3x squared, 3x to the power 5 minus 2x plus 4. So let's say we also have y, which is equal to, let's say, the square root of x. They have said differentiate y is equal to square root of x. Now, we already did indices, and we said when you've got something in a square root of a number, this is the same as that same number. This square root is the same as to the power 1 over 2. So this means that this is the same as y is equal to x to the power 1 over 2. Okay, and then you are going to bring now. So of course there is a 1 here, even if you can't see it in front of x. So there is a 1. So we are going to multiply this half with the 1 which is in front here, which you can't see. So that will still give you half. And then you write the x. Now the 1 over 2, subtract a 1. So you say 1 over 2 minus 1. This will give you negative 1 over 2. So this is going to be half x to the power negative 1 over 2. Now from the indices, remember we did indices. We said if you have got a negative power, so this is basically, I can also say this one which is on top times x. So that is going to give us x to the power negative 1 over 2 divided by the 2 in the denominator. If you have got something with a negative power, you can bring that down. Okay, so that will become 1 over 2. When you bring this down, the power is going to now become positive 1 over 2. And so this means that your answer is going to be y is equal to 1 over 2. Now if you've got x to the power 1 over 2, that's the same as square root of x. So this is the answer. The square root, the integral of square root of x is 1 over 2 square root of x. Is that okay? Alright. Now, differentiation is very important. Why is it very important? Because it is used as a gradient function. So actually, when you have got, let's say they've given you a curve y is equal to 3x squared minus 6x plus 4. Let me just say plus 1. They say, given this curve, find the gradient of this curve at the point 1, 0. So I want to find the gradient of this curve at the point 1, 0. How can you find it? So to find the gradient, you say dy over dx. That is going to be equal to, you get the 2, which is the power multiplied by the 3. It is going to give you a 6. And then you write x, 2 minus 1, that will give you 1. So it will just be 6x. And then here, when you just have an x, if you differentiate that, the answer will just be negative 6. Now when you differentiate 1, you are going to get what? You are going to get 0. Every time you differentiate something that doesn't have x, you always get 0. Right? So it will just be 6x minus 6. So to find the gradient where there is x, you are going to put the x value, which is 1. Because this is the x value, this is the y value. Right? So this is going to become 6 multiplied by 1 minus 6. And this will give you 0, meaning that the gradient of this line is 0. Okay, that's the gradient, 0. Now, when you have got a curve, let's say this, you've been given a curve on a Cartesian plane. The x value there and the y value here. Okay, this is, you have got a curve more like that. Let me put it here, it goes like this. Okay, so this is the curve and it's going to have an equation, maybe y is equal to something. Let me say the equation of this curve is y is equal to, let's say, what can I say? Let me say 2x squared minus x minus 6. Okay, let me say this is the equation. So meaning that for this one, for this curve which you are able to see here, you have got what is called a tangent to the curve and also the normal to the curve. Now when you are talking about the tangent, a tangent is a line that touches the curve at only one point. So if you see where this curve is turning here, at just one point, okay, so you can draw something like this, a line like that, which will only touch at one point. That's called a tangent. Or even somewhere here, a line that is going to touch only at one point like this, it touches somewhere here, that is also a tangent. Okay, now let me show it at the end here. So a line that is going to pass like that, it only touches at this point. That is what? That is called a tangent. What is a tangent? A line that touches a curve or a circle at only one point. Now there is another curve which makes 90 degrees to the tangent. Like it goes like this. Let me use a different color for that one. Okay, it makes 90 degrees like that. So what 90 degrees, you can see that this between the tangent and that line, that angle there is 90. So this line we call it the normal. The normal. So this gives us what we call tangents and normals. Now for the tangent, since the tangent only touches the curve at one point and it's more goes like parallel, although not necessarily parallel, but just a line that touches the curve at one point. So to find the gradient of, now you can see that the tangent and normal, those are straight lines. The curve is not a straight line. Okay, to find the gradient of the tangent, the one which touches the curve at one point, actually dy over dx, which we call the gradient of the curve, is going to give you the gradient of the tangent. Now m is the symbol for gradient, and dy over dx is a symbol for gradient of a curve. M is a symbol for gradient of a straight line, meaning that the gradient of a curve is equal to the gradient of the tangent. Okay, now from coordinate geometry, when you have got two lines like this which are making 90 degrees, if you get the gradient of this one and the gradient of this one, you multiply them. So you say m1 multiplied by m2, you are going to get -1. So since the normal makes 90 degrees to the tangent, meaning that the gradient of the normal multiplied by the gradient of the tangent, it should give you -1. So using this principle, they are going to ask you to find the equation of the tangent of the equation of a normal. Okay, let's have an example. Let's say we've been given an equation y which is equal to 2x cubed minus 4x squared plus 2. Okay, so the question is find the equation of the curve, not the curve, but the equation of the tangent and normal. So we're going to give us 2 points where we need to find the equation of the tangent and normal. For the first one, for A, we are going to find at the point 1, 2. Okay, that's the first one we're going to find. And then for B, we are going to find at the point when x is equal to 0. Let's start with the first one. We want to find the equation at the point 1, 2. So the first thing you need to do is you need to find the solution or the gradient of the curve. How do you find the gradient of the curve? You need to find the derivative of this curve. So dy over dx is going to be equal to, you get the 3 multiplied by the 2, that is going to give you 6x, and then the 3 you remove a 1 to be power 2, then minus, get the power 2 multiplied by the 4, that is going to be 8, then you have got x, since if you remove a 1 from 2 to just be 1, right? And then for a constant, every time you differentiate a constant you always get 0, so that one will not even show it. Now where there is x, I'm going to get this x value here, I put there. Okay, so that is going to give us, let me just write it this side, 6 multiplied by 1 squared minus 8 multiplied by 1. So 6 multiplied by 1 squared is just 6, negative 8 by 1 is just negative 8. So 6 minus 8, the answer is going to give us negative 2. So this is the gradient of the curve. Since it is the gradient of the curve, it means it is also the gradient of the what? The tangent. So it's the gradient of the tangent is equal to negative 2. So to find the equation of the tangent, you need to know this one. Y minus y1 is equal to mx minus x1. So this is how you get to find the equation of a straight line. So you need to know this one. How to find the equation of a straight line, you need to know this. Okay, so here we've been given this is the x value, this is the y value. Now I'm going to call this as x1, I'll call this as y1. So where there is y1, I'm going to replace that value. Where there is x1, I'll replace that value also. So I'm going to say y minus y1, you can see this is a 2. That is going to be equal to, now is this point even on the curve? Okay, this is a point that I just picked randomly, so it might not be on the curve. Okay, so let me just say it's 1, 3, but it might not be on the curve because I didn't calculate it. So meaning that y1 is going to be 3, and then m, which is the gradient of the tangent, to find negative 2. So that's the one we're going to substitute here. And then we'll say x minus x1, this is a 1. Okay, so this is going to give us y minus 3 is equal to negative 2 times x. That is going to give negative 2x Negative 2 times negative 1, that is going to be positive 2. And this will give us y being equal to, I'm going to take 3 this side, so it becomes positive. So I'm going to have negative 2x. The 3 goes the other side, it will be 3 plus 2. That is going to be a 5. So this is the equation of the tangent. Okay? So if you want to find the equation of the normal, remember we said the normal and the tangent, they make 90 degrees. So if I multiply the equation of the tangent, so I'm going to say m1 multiplied by m2, supposed to give us negative 1. So the equation, the gradient of the tangent, let me call it m1. And we've seen that's negative 2. Multiplied by m2, this should give us what? Negative 1. So divide both sides by negative 2, so it will just remain with m2. So m2 is going to be equal to negative 1 over negative 2, which is just 1 over 2. So meaning that the equation, will just use this same one which is here to find the equation. So that is y minus y1, you can still see is still 3. And that will be equal to m, that's the gradient, and the gradient is 1 over 2 now, because this is a tangent, the normal we are talking about. And then x minus x1, x1 is still the same value, which is a 1. Okay, from here, now since you can see there is a 2 down here, I don't want to have that 2. So I'm going to multiply everything. I'll do this. I'll get this number which is down, which is a 2. I'll multiply. So I'm going to say 2 times y, that is going to be 2y. And then the same 2 times 3, that is going to be negative 6. Now if I multiply this 2 and the half, they are going to cancel, like 1 over 2 times 2. This 2 and this 2 cancel out. Okay, so what is going to remain is just a 1. So this one which remains 1 times x, that is going to be x. Then 1 times negative 1, that will be negative 1. Meaning that the equation is going to be 2y is equal to x. I'll take this 6 the other side, becomes positive. So positive 6 minus 1, that is going to be a 5. Positive 5. So this is going to be the equation of the normal to this curve. Is that okay? So for b, when you want to solve b, for b they've only given you the x value, meaning that for each, before you solve it, you first need to find the y value. So to find the y value, you are going to come in the actual function which has been given here. Okay, so I'm going to say that y is equal to 2, where there is x you put 0 to the power 3 minus 4, where there is x you put 0 to the power 2, and then plus 2. So this is 0, this is also 0, so the answer will just be 2, meaning that y is going to be 2. Okay, meaning that the coordinate that we have, the x value is 0, the y value is 2. So the coordinate that you have is 0, 2. So the first thing, also find the gradient of the curve. Now we already found the derivative, right? dy over dx gave us 6x squared minus 8x. So now where there is x, put 0, that's the gradient. Okay, so this is going to be 6 multiplied by 0 squared minus 8 multiplied by 0. And this is going to give you 0 as the gradient of the curve. Remember, the gradient of the curve is equal to the gradient of the tangent, meaning that that's the gradient of the tangent also, right? And then from here, let's also find the gradient of the normal. Now for the normal, you know that m1 multiplied by m2 is equal to 0. So if I put the first gradient to found 0, so this is 0 multiplied by m2, that is going to be 0. 0 multiplied by m2 is 0. So this one doesn't exist. In other words, we don't have the gradient of the normal, right? It doesn't exist. Okay? It doesn't exist. So to find the equation of the tangent, first. How do you find the equation? Using the same one. Y minus y1 is equal to m x minus x1. So this is going to be y1. You can see we found y1 as what? As 2. That is going to be equal to m. M is the gradient we found 0. Then x minus x1, that is a 0 also. Now when this 0 multiplies anything here, it will still be 0. So I'm going to just have y minus 2 being equal to 0. So find that y is equal to 2. This is the equation of the what? This is the equation of the tangent. And to find the equation of the normal, you'll just look at the coordinate that we found. We found 0, 2. This value here, that is going to give you the equation of the normal. It is x is equal to 0. This is the equation of the normal. Like if you see the coordinate, it means that you are talking about the curve is going to move something like this. So you want at this point. So at this point, the tangent is passing like that. That's why we say the equation of the tangent is y is equal to 2. The normal is going to make 90 degrees. So the normal will just be along the y-axis. That's why the equation for the y-axis is x is equal to 0. That's the equation for that one.